So hello everyone. Today I'll be presenting about ARIES. The name of the paper is ARIES, a transaction recovery method supporting fine granularity locking and partial rollbacks using write-ahead logging. To put it in a very simple put it in simple terms, this paper is related to recovery and how a process in which ARIES recovers the data, right? So that's all. So let's get started. So ARIES is like a robust transaction recovery method that addresses key challenges in database system, particularly in supporting fine granularity, and it also looks at granularity locking and partial, and it uses partial rollbacks while doing write-ahead logging. Right, lots of terms, but I'll explain all the terms later. So let's get started. The first thing is I have divided this presentation in 4 sections. The first sections, it will be a simple introduction and core principles related to ARIES, where I explain you about core terms and stuff like that. Second section will look at data structures and different normal processing related to this. Third one will be like key things like how to do restart, how to recovery, right? Whenever something crashes, how do we initiate the recovery process, stuff like that. And in the final section we'll talk about ARIES, we'll compare it to other systems and talk about the impact of ARIES. So talking about the introduction, it says ARIES, what ARIES does is it deals with transaction recovery, right? But how? It does it by supporting partial rollbacks of transactions. That means you roll back the transaction and see each step. You count, you go back, you check on each step, and it suppose fine granularity and locking and recovery using write ahead logging. We'll call it well. This is something you need to remember well. So why transaction recovery is needed, right? Because it is important that our data remains consistent, right? So we do not want the data to be corrupted somewhere due to any errors, and we need to make it consistent so that our database management system remains durable. And the thing to remember about ARIES is it uses a approach called no force approach, right? So we talked a little bit about ARIES, but what are the challenges of traditional methods? The thing is, traditional methods struggle a bit with acid properties like atomicity, stuff like that. And another thing is, traditional methods are a bit complex and they are inefficient whenever they need to handle fine granularity locking. So next thing will be I'll tell you a bit about the three main ideas of ARIES. This is the main concept and everything revolves around this. So write ahead logging, repeating history during redo, and logging changes during undo. So what happens in write ahead logging is any change is recorded in log on stable storage. Before that change is in our database, it is written database. It's before the change is in the final text, it is written in our database. That's how it's work. And we must use these two things, the steal plus no force buffer pool policies. Secondly, we need to learn a little bit about repeating history during redo. Whenever we restart, we retract the actions and restore the database to the exact state before the crash. So finally, we do logging changes during undo. We need to record undo action, so to sto log to ensure the action is not repeated in the event of repeated failure. So if there are multiple failures, we need to record all the actions in our log. So this is a brief overview. It's like a very simple diagram how it works. So any change to the object is first recorded in the log, right? And then the log must be returned to the stable storage. So it's like this: there is a log, it goes to previous log, keeps on going back in the sequence, and it reaches the final destination. So this is the log sequence, and it's a very simple explanation of how it works. So talking about the core principles of ARIES, there are like, first one is like repeating history, second one is like page oriented redo, and third one is like logical undo. So ARIES is built on these three principles. So repeating history means that during recovery all logged updates are repeated to restore the database to its exact state before the failure, regardless of the transaction commit status. Okay. Second one means that page oriented redo optimizes for the recovery by focusing on individual page. And third, logical undo allows the undo operations to be performed logically, which improves concurrency, and this avoids the need for strict page level locking during undo. So next thing will be around CLR. So CLR stands for comprehension log records, right? So what they do is they record during rollbacks containing redo information so that undo operations can be redone if necessary. What this does is this ensures that undo operations are independent, repeating them doesn't cause inconsistency, right? And it prevents issues like compensating compensations. And CLRs also support logical undo, which enhances the concurrency of our system. So so I'll talk about section 2 now. So let's talk about data structures and normal processing related to ARIES. So the first one is like log record, second one is like transaction table, and third one is like dirty pages table, right? So ARIES utilizes several key data structures, right? The first thing, log records, and what it does, it records every change, which forms a chronological change of events. And the second thing is transaction table. What it does, it keeps track of active transactions and their status. So keep track of active transaction and their statuses, which are important during the recovery process. So yes. So finally, the third thing is called dirty pages. So what it does is the dirty page table, right? The dirty page table monitors pages that have been modified but not have been saved yet to the disk, and it helps ARIES to identify what needs to be redone after the crash. So log records contains LSN, operation type, transaction ID, prev LSN, page ID, undo next transaction, and data modification, stuff like that. Transaction tables also contains transaction ID, status, and this status could be active, committed, aborted, and last LSN. This one I showed you in the figure before. So dirty page table, it contains page ID and rec LSN, which stands for recovery LSN. So now let's talk about normal processing, right? Normal processing related to ARIES. So during normal operations, when a transaction modifies data, ARIES logs the update, and those updates pays LSN to match the log to the recorded LSN. So whenever transaction happens, the tight linkage, there is a tight linkage which is between data page and log records, which is fundamental for ARIES, and this ensures that each page change is properly tracked and can be recovered if necessary. So that's it. First one will be like the data, and second one how they link that data. So next thing to know will be about normal processing rollbacks. So when a rollback occurs, ARIES processes the transactions log records in reverse order, undoing each action. For every undo operation, a CLR is written to record that action. Okay, so the next undo, next LSN field in CLRs will point to the next log record to undo, which is particularly helpful because it helps in managing nested rollbacks efficiently. So first thing is processing log records in reverse order, second one will be writing CLRs for each undo action, and the third thing is handling the nested rollbacks. So finally we have to now commit. For commit processing, especially in distributed environments, ARIES uses two-phase commit protocol to ensure atomicity, right? Transaction log prepare record which they are ready to commit, and commit records to the finalize. For pending actions that can't be undone immediately, what ARIES does is it locks special records to handle the handle them appropriately during the recovery. So yes, these are like there is a two-phase commit protocol, and there is like logging, which logging and preparing the commit records, and finally handling the pending records. Now the next thing will be to related to normal processing checkpoints. So ARIES uses fuzzy checkpoints that can be taken without pausing system operations, right? So these checkpoints, what they do is they capture essential information like active transaction and dirty pages, which reduces the work needed to recover by providing a snapshot of the system. It provides the snapshot of the system at that time, at a point at that time in certain point, right? So what you do is you take the fuzzy checkpoints, then checkpoint records. So what does the checkpoint record contain? They contain a list of active transaction, contents of the transaction table, and contents of the dirty page table, right? So how is it beneficial? Talking about it benefits, it reduces work during restart recovery, and it provides a snapshot of each system state. So now let's begin to the section 3. Section 3 is related to restart, recovery, and advanced features. So analysis, redo, and undo overview. Like this is like with this you can see the very high level representation and a simplified representation of how this works. There are like three phases. The first one is analysis, then second one is redo, and third one is undo. In the analysis, you figure out which transaction committed and failed since checkpoint, right? Something had to crash somewhere, right? So this thing does the analysis part. And second one, we repeat all the actions. In second, this one is called redo, and you repeat all the actions you did before, right? This part. And this, all of them are related to time and time of the crash. So finally you reverse the effects of the failed transaction, and this is called undo. You can see redo and analysis go in one direction, but undo goes in the opposite direction. So this is something that you will have to remember. Yes. So the first thing is restart, recovery, and analysis pass. So the analysis pass is the first phase of recovery in ARIES, right? It's what it does, it scans the logs starting from the last checkpoint to reveal the transaction and dirty pages tables. The secondly, what it does is identifies which transactions were active, which transactions were active and which pages were dirty at the time of the crash. So it what we do is we determine the starting point for the redo pass. So you can also see it here. We determine the state of the database. The purpose is to determine the state of the database at failure. Actions, what do we need to do in order to this? We scan the log for the last checkpoint forward. We reconstruct the transaction and dirty pages table, and we identify the redo LSN for the redo pass. So finally, we identify transactions to roll back and transaction which are active at the time of failure. So let's go back. So now we go to the redo phase. Restart, recovery, redo phase. In this redo phase, ARIES replace all the logged updates starting from the redo LSN, including those from uncommitted transactions, right? So then this repeating history ensures that database is restored to the exact state it was in before the failure occurred, and it provides a consistent foundation for the undo pass. So starting from these are the steps. You start from the redo LSN, you include uncommitted transactions, and ensure database state restoration, right? So what it does is restores the database to its exact state before failure. So let's go to the undo section. In the undo section, the undo pass addresses transactions by processing the log records backward, undoing each actions, right? As it undoes the operations, ARIES writes CLRs which help manage the undo process efficiently. We use undo next, the thing called undo next LSN. in CLR, and it ensures that if recovery is interrupted, ARIES can resume undoing from where it left off without any inconsistency. So this is how it works. So simply you start from redo LSN, you include uncommitted transaction, and it ensures the database state is restored. So you one thing to remember is you can redo undos, but you cannot undo n undos, right? So finally, the part will be to recover the media, right? Media recovery in ARIES usually deals with failures involving data loss, like disk crashes, right? How it does it by using fuzzy image copies. What it does, it takes snapshots during normal operation, and ARIES can restore the data without shutting down the system. And this recovery involves reloading the image copy and reapplying log changes to bring the data up to date. So that's handling data loss failures. This one is in disk crashes, and it uses fuzzy image copies, and the recovery process involves reload the image copy, perform the redo scan from the media recovery redo point, and apply relevant log records to the update data. So now let's talk about nested top actions, right? ARIES offers, what it does, it offers several advantages over traditional recovery method. How? Yeah, first thing, it supports fine granularity logging, which enhances the concurrency of the system, and it helps handle the rollbacks efficiently, which allows for the transaction to undo parts in their work without aborting entirely. And it also follows a flexible buffer management and minimal storage overhead, which makes it quite suitable for various systems, right? Without imposing constraints on that data representation. So the concept is to allow certain updates within a transaction to be committed even if the transaction fails, right? Second one is use cases, operations like file extensions or updating systems metadata, and the mechanism will be like to writing a dummy CLR, and it prevents undoing these specific actions during rollback. So now let's get started with section 4. The section 4 will be in the top view. It's like what are the advantages of ARIES, the impact, and final conclusion related to this paper. Now let me tell you about advantages of ARIES. So it offers several advantages over traditional methods, right? What it does, it supports fine granularity logging, which enhances the concurrency of the system, and it helps in efficiently handling partial rollbacks, which eventually allows the transactions to undo parts of their work without aborting that process, right? And it is also flexible in buffer management, and it needs minimal storage overhead, which make it quite adaptable for various systems. And it doesn't impose any constraints on a data representation. So first thing will be to support for fine granularity logging. Second one, it is efficient. It has flexible buffer management. It also requires very low storage overhead, and there are no constraints on its data representation. So talking about high concurrency and performance, ARIES uses what we call logical undo operations, right? And this avoids the need for strict page level logging during undo process, which significantly increases systems concurrency, right? Because the logical undo operations. The second thing is the repeating history principle simplifies recovery logic, and this ensures consistency. So it's like we have a process and we follow that repeating history process every time, right? Together with efficient checkpoints and recovery management system. What ARIES does is it reduces the downtime and enhances the overall performance, because because it is more efficient. So next will be comparing ARIES with other recovery methods, right? So Compared to traditional recovery method, ARIES stands out for its efficiency and how it handles fine granularity locking and partial rollbacks without it needing to pause the system for the operations. It also has the ability to manage complex transactions and provide good and strong recovery in high concurrency environment compared to its counterparts. So those are the advantages of ARIES. Now let's talk about the impact of ARIES. Talking about the impact, it has a good influence in modern database system because principle of ARIES have been adopted quite widely. Talking about its applications, it is used in persistent object-oriented language, recoverable file systems, and end-way data sharing environments. So there are few things we need to consider in ARIES as well, and it has some limitations too as well. So while ARIES it has a very robust framework, right, it is important for us to consider that the primary source focuses on technical aspect. Additional research may be necessary for us to fully understand ARIES performance, because under extreme conditions such as whenever we have very huge volume transaction and such kinds of environment, or conditions when there are very frequent failures, how do we do it? And this may help us optimize the performance while we are scaling these systems and using ARIES for it. So finally, to give a conclusion, I'll say that ARIES has a comprehensive and efficient approach to transaction recovery, and I find this system to be quite logical too as well. Right? You go back each step. You keep on going back one step at a time, and to figure out how to solve the problem. Right? So the key principles like repeating history, page-oriented redo, logical undo, and CLRs, they are quite impressive and important as well. So significance will definitely be to make a critical challenges in database recoveries, and it has definitely a bus in that. It also continues to influence modern data management technologies even today. So finally, has definitely enhanced system readability and performance. Further exploration, we may further explore how ARIES works and look at its efficiency. But it is a very good system and very logical and easy to understand and easy to use as well. And the thing is, it doesn't require very huge memory bandwidth. That's why I think ARIES is very good. So thank you.